Hi, so today we're going to start our new unit in honors. It's the equations add-on, 7th grade honors unit. Here's our table of contents, and we're going to jump right in with lesson 1. Now, this material is pulled from lots of different sources, so like this is lesson 3. It's the first lesson we're doing. So, looking here, figures A, B, C, and D show the result of simplifying this hanger by removing equal weights from each side. Here are some equations. Each equation represents one of the hanger diagrams. So, we're going to try to match them up. Let's call this X and Y. So then we have X again, Y, Y, Y. So here's kind of my key for the square. I'm calling that X. For the triangle, I'm calling it Y. So let's call the circle Z. And that's just kind of my key that I am using. So, then on this side, I would have Z, Z, X, 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 Y, Y. So, it looks like I have, this is kind of repeated. So I have two sets of this X plus 3 Y's, and then I have 2 extra Z's. So it's looking like it might be this third one here, C. So let's see, 2 Z's, 1, 2, 3, 4 X's, and 2 Y's. So C matches capital letter A. This equation, goes with this diagram. All right, let's move on to B and see which equation matches it. So A, we can put that here, went with C. Okay, so using our same key that we developed, I've got X, Y, 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 X, Y, Y, Y. So it's almost like I've divided, cut that in half, this part here. So I've got 2 groups of this, 2 groups of X plus 3Y. So it's looking like it might be this one. And then here I've got X, 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 Y, Y. So I have 1, 2, 3, 4 X's and 2 Y's. And that is option A, little C up here. So for B, that was little a. Okay. And we have another one. And we're just matching these up, which goes with which. So here's X, Y, Y, Y. And we have X, X, and Y. So we have X plus 3Y equals 2X plus Y. And that is D, little d. That goes on to the next page here. Okay. And then that's capital C here. One more to do. The triangles were Y, Y, so 2 Y's equals X, which is little b with my options. So I'll go here and put a little b. Now, each variable represents the weight of one shape, which goes with which. So we figured that out. The triangle was the Y, the circle was the Z, and the square was X. We actually figured out pretty quickly how to do that. Explain what was done to each equation to create the next equation. It says if you get stuck, then think about how the hangers changed. So we look at the hangers, from this hanger A to hanger B, I no longer have the circles. So here, 2Z was removed from each side, from this one to this one. Looks like everything was cut in half, so I divided by 2. Let's see. Here I subtracted 2Z to get to here. And I divided everything by 2 to get to there. And here, looks like I am subtracting one triangle from each side, or subtracting one Y to get from here to there. But I think the key thing to remember is the same thing is happening to each side of the hanger. And if we want to, we can even say to each side of the equation. So first we subtracted 2Z, then we divided by 2, then subtracted 1Y. These are kind of the steps that they took. Okay. The next thing says your teacher will give you some cards, and each of the cards, 1 through 6, shows 2 equations. Each of the cards, A through E, describe a move that turns one equation into the other. So you're going to match each card, the number with a letter. And one of the letters will not have a match. And then for that one, you can write 2 equations on your own. So, this is going to be actually the last page in your folder, but you can tear it out and then cut it up. That way you can work through it. Okay, so here's what that page looks like. And again, it's the last page in your folder, your printout. So I'm going to pause this and I'm going to cut it up. That way I can match them up. And you should do this as well. You should actually go ahead and try to match them all up before you start the video again. You're just trying to match what has happened with the words that describe it. So pause the video, and then after you've done that, you can turn it back on and check your work against mine. But I'm going to go ahead and get started here. So it looks to me like when I compare this to what's now there, it looks like I've subtracted 3x. And if I did that from the other side, that's what I would end up with. So it's subtracting 3x from each side. And I'll find that in a minute. This is my process. Okay, so the next one, I'll try to do them in order. Number 2, looks like I've divided everything by 3. Because when 12x divided by 3 is 4x, 3 divided by 3 is 1, 6 divided by 3 is 2. But I'm expecting it not to say divided by 3. It'll probably say multiplied by 1/3, which is the same as dividing by 3. But we'll see when we get there. All right, the third one, okay, this stayed the same as this. Looks like I subtracted 3, so if I subtract 3 here, I also get the same thing. 4 minus 3 is 1. Okay, then the fourth one, looks like I'm multiplying by -3, so that I no longer have this fraction part, 5x, and then 12 times -3 is -36. So I think this one is multiplying by -3. Number 5. This one is interesting. See, this is that. So looks like I'm dividing by negative 3, which would cancel that, and then I would end up with negative divided by negative is a positive. Okay, so I'm dividing by negative 3, which is multiplying by negative 1/3. And the last one is the blank one that you're going to fill in yourself. So multiply, well, I guess I'll start with A. Okay, A, multiply each side by negative 1/3. So I got 5 for that. Okay, running out of room. Okay, multiply each side by negative 3. Okay. Add negative 3x to each side. Alright. Might need to make that. Yeah, that might help. I don't know. Here's 1. Okay, 2 is multiplying each side by 1/3. 3 is adding negative 3 to each side. 4 matches up with F. 5 matches up with A. And for 6, you're going to write 2 equivalent expressions. You're going to make up your own example like this with equations. And then you'll add 3x to each side to can go from one to the other. So let me just make up a question to help you. Negative 3x plus 2 equals negative 2x plus 1. So then if I added 3x to each side, I would get 2 equals x plus 1. So that's just one example. You make up your own. All right, so there's that activity. And let's see how much more of this lesson there is. I think we can squeeze it in. Okay, so when I look here, it seems that Noah is distributing first. That would be 2a minus 6. Then Noah divides each side by 12, and a negative divided by positive is a negative. So he is correct. Okay, oh, she has the same answer. Let's see what she did first. Looks like she started, let me write down what he did. He distributed first. Now she divided by 2 on each side first. But she did that correctly. 14a divided by 2 is 7a. And then she subtracted a from each side. And finally divided by 6. And she is also correct. So they are both correct. Which now takes me to the last part. Okay, so we have 2 more questions, and these questions give us an equation and say what do you recommend they do first. So it would be okay to do it either way, but we're looking for compatible numbers and what's going to work best. So I see that 15 and 10 are divisible by 5, so I feel like I'm going to divide by 5 first, or I could also say multiply by 1/5, because these numbers will end up working well with dividing by 5. Now if I tried to divide these numbers by 4, that's not going to be too pretty. I'm going to end up with a fraction. Now I can use 3/4, but maybe I don't prefer to work with fractions. So I think for this question I would probably go ahead and distribute first, and that way I don't end up with 3/4. So just kind of look ahead and think about the questions that you have before you just jump right in. Think about how the numbers work together or not. Then you have a summary and a problem set to do. Thank you.